different algorithms have different costs. And we want to see how to use that to reason about the expense of doing something and better ways of finding a solution to different problems. So here's our roadmap. I did before I came in to capture this lecture. There are about 45 billion pages right now on the World Wide Web. On average, there are about 100 words on a page. And for sake of argument, let's assume if we want to find a word on a page, it's going to take us about 10 operations to try and find that, whether that word is on that page or not. We'll see later on how we could get it down to about 10 operations. That says, if I'm going to just brute force try and search everything on the web to see if I can find the thing I'm looking for, it's only going to take me about 5.2 days to find something. You probably don't want to wait that long. So even with a very fast machine using these simple calculations, it's not going to be enough. How about playing chess? An expert will tell you there are about, on average, 35 moves for every setting on the chessboard until you get to the end game. Suppose you want to look ahead 6 moves in order to try and decide what you want to do in order to beat your opponent. That says you've got about 1.8 billion boards that you need to check. And if it's going to take you, for example, 100 operations for every choice, it's going to take you about 30 minutes to decide each move. Probably too slow. And this is simply a way of saying that even with fast computers, we need cleverness, we need algorithmic thinking to take those simple computations and turn them into something more powerful. And that says good algorithm design is going to be crucial, and it's one of the skills you're going to learn throughout this course. What about storage? Got lots of storage in a machine. Why don't I just compute everything once?
Okay.
Okay, which is if we want a computer to compute something, we can ask, well, what's the knowledge that it's going to use to do that computation?
I don't like
And
this
that
auto
actually leads to an
scroll.
interesting distinction, because we can
I wish I
divide
could
knowledge into
listen
two
and read at the
types.
same time.
What we're going to call declarative knowledge and what we're going to call imperative knowledge. Declarative knowledge, those are statements of fact, statements of truth. For example, if I were lecturing here at MIT, I might have gone in ahead of time and strapped some or taped some candy under one of the chairs inside the lecture hall. An imperative piece of information simply says, There's candy taped to the underside of a chair. It doesn't tell you anything about how to find it. It doesn't tell you where to look.
What the fuck?
Look for it. You'd either have to do it in parallel by having every student reach under the chair or search the entire lecture hall. It's simply a statement of fact.
Got a phone call? Hello? Hello? Hello?
It's attributed to Ali. If G times G, if G, and you can see that at a little graph at the bottom. With that better, we've described a recipe. We said it's a sequence of mechanical steps. It's going to capture the sequence of things I want to do in order to compute something. But now I want to get it inside the computer. I don't want to just give it to my friend and have him do all the work for me. So the next question is, I'd like to get a machine that's going to compute square roots for me. Historically, there were two choices here. The first one was to use what was called a fixed program computer. And this would be a computer designed specifically to calculate a particular computation. You've actually seen them. Actually, you may be too young to have seen them, but people my age have seen them. Handheld calculators were a fixed program computer. They did addition, subtraction, multiplication, a simple set of arithmetic. Very famous historical example was Alan Turing's bomb. This was a machine designed is emulating basic machine architecture of a computer has some simple pieces. It's obviously got some memory, places in which I'm going to store things. Now, up here in this memory, it could be data. But it also could be a sequence of instructions that are my program, that mechanical set of steps. I haven't said exactly what they look like, but you got a sense of them from what I did in that square root example. I'm also going to input and output. We'll come back to those later on. The first is often if I'm going to do an operation that takes two inputs, is going to do a primitive operation. And when I ask To summarize, a stored program computer then is going to be that sequence of instructions. It's going to be built out of simple arithmetic and logic instructions. It's going to be built out of simple tests. And it's going to allow us to move data around. And associated with that is going to be this special program called the interpreter that's going to execute each of those sequences.
This is the talk I was just having. Am I dev yet? No. It's be simple. Execute each order.
In order, changing things with the flow of control when a test says, I want to go somewhere else. And then finally, when I'm done, print out the answer. That sounds great. So what are the basic primitives? Most machines will come, as I said, with simple arithmetic and logic operations. But in fact, you can go even simpler than that. And if you go back to that gentleman I mentioned earlier, Alan Turing, one of the greatest computer scientists in the history of the world, Turing showed that you can compute anything with just 6 primitives. In fact, there's something called a Turing machine, an example of which is shown in that little image on the slide. A Turing machine is an infinite tape with a set of squares on it. In that, each square there's a symbol, could just be a 0 or a 1. And what Turing showed is if you have 6 operations, and those are move left, move right, scan, read, write, do nothing, with just those 6 primitives, you can compute anything that's computable. You're now panicking and looking to find a different class, because if what you had to do was program a computer by saying move left, move right, read, write, scan, stop, you don't want to program. Fortunately, modern programming languages come with a more convenient set of primitives. But the fundamental idea is that with a simple set of primitives, you should be able to compute anything. Equally importantly, you don't want to just write everything in terms of addition, subtraction, logical tests. What you want to do is write descriptions, like that square root program that we talked about earlier, and then abstract them. And I'm going to highlight that word because abstract is going to be really important. You want to treat that square root as if the manufacturer had built a little primitive and installed it in your machine. You want to be able to use it as if it was something that came with the machine. And that's what the power of computational thinking is going to give us. One last thing about computation. Let's go back to that Turing machine idea. I said you could compute anything if you just had those 6 moves. There are some nuances to this. A more sophisticated computer scientist could debate some of those details. But there's a fundamental property which says anything that's computable in one programming language is in fact computable in any other programming language. Wow.
Pow.
That's amazing.
Did someone say?
Well, you may get heated debates between people about whether Python or C or...
Who's there? Oh, hello. Oh, I can't hear you anymore, Edgar.
Hello?
Hello, I can hear you again.
Oh. Did someone say nuances?
I think he did say nuances. In fact, I can go back up. There are some.
There's some nuance. There's some nuances.
All right.
So this more sophisticated computer scientists could debate some of those details. But there's a fundamental property which says
wait, I gotta go.
anything that's computable. There's some nuances. There's some nuances to this.
Okay.
A more sophisticated computer scientist
Oh, I can
could
speed this
debate
guy
some of
up.
those details. But there's a fundamental property which says anything that's computable in one programming language is in fact computable in any about whether Python or C or Fortran is the best computer programming language. They're all the same. Okay, slight misstatement. Some are going to be easier. Let me rephrase that. In some languages, it's going to be easier to do some kinds of things than others. In MATLAB, it's easier to manipulate.
I can hear you.
indices. In C, it's
Who is
easier to
this?
deal with web programming.
I do.
But nonetheless, any
Oh, what's up, Daddy?
you can
Are you
compute
watching
in
my
one
stream?
language, you can compute in any other language.
I'm not actually. Is
Oh,
that
okay.
should I?
Called
No.
Turing Complete.
I'm listening
One
to a
of the
lecture
You're
on
required.
stream.
fundamentals of computer science.
I'm listening to a lecture on stream, and now I'm about to take a quiz on stream.
Ooh.
Exercise 3. Okay. True or false? A stored program computer is designed to compute precisely one computation. False. A fixed program computer is designed to run any computation. False. A program counter points the computer to the next instruction to execute.
We're all just gonna snicker.
Oh my god.
I
I
wrong,
don't
we're all like,
I don't know if three's right. What does it mean when we say that the computer walks through the sequence executing some computation? False. Oh no, I got 4 wrong. Yay, okay. That was what my other question was. Let's look at the comments. With the square root example, you have to jump back to the beginning. Okay, I was counting the jump back to the beginning as part of like a linear sequence of steps, but that's okay. Doesn't really matter. Alright. Languages. Let's just try. Man, this stuff's actually pretty detailed. So I'm just discovering.
So now we've got the idea of creating a recipe as a generic idea. We know a little bit about what's inside the machine. What we need to do is put those two things together. We want to now go from a description of a process to a specific set of statements that we can store in the
what was
machine
Brandon saying?
so that
This
that
course is
interpreter,
real.
that evaluator,
What did he say?
I don't think it goes through gates and stuff.
can then run
I
those
did
operations
Anusha.
primitives inside the machine.
What's up?
Well, no, Anush and I did the Anush did the lectures for like a little bit,
Oh, okay.
and like I think it doesn't take that long, but the beginning definitely does at least. It's more like I think it's a more in-depth intro than is typical for.
An intro to programming type thing.
Well, I shouldn't say for an intro to programming. I mean, I think the university course is sometimes appropriate to do this type of thing, but I don't think it's going to be like the EE 306 where you're doing like logic gates and assembly. I think.
Oh yeah, this is a lot more like.
I think once you get past the intro, it's going to start teaching like actual programming concepts rather than like, oh, this is the programming model of a computer.
I'm actually pretty like this stuff's pretty like interesting to me, and it's like sensible, and it's like stuff that I probably could like think of or myself or like digest pretty easily. I just want the stream to be more exciting.
Oh, well, that's gonna be hard. Yeah.
So that's why I want to
As we
have
said,
some like
programming language is going to provide us with a set of
problems.
primitive operations. And the next step is to start talking about how do we put
But I do
them
want to
together.
go through this in order.
To do that, we use something that we call an expression. And the expressions in a
But I
language are
could
simply
speed
more
through this
complex.
by just
but
reading the transcript. Expressions, legal combinations of primitives.
See, it's already beginning to get to actual programming concepts. It's talking about expressions, values, operations.
Put this up. So you're finally getting stage of getting to the place. It's kind of like what you just said. This guy, it's like we're finally at the stage, getting to the place where we're going to begin to get the computer to do something. It's like kind of what you just said.
Mm-hmm.
Okay. Any legal expression has associated with it a value, which is the meaning of the expression. It's going to be important in part because if we know we want to get to expression, blah, blah, blah. Okay.
So let's look at how we put this together. Every programming language can be thought of as consisting of a set of primitives, a means of combination, a way of putting those primitives together to create new expressions, and a means of abstraction, a way of taking some complex expression and treating it as it's a primitive.
You see, because like I did some for my anthropology degree, I did a lot of like, not a lot, but I did a decent amount of like linguistics classes, and like it's interesting to think about these things in those kinds of terms.
Yeah, I mean the like the parallels between like natural language syntax and
Yeah,
programming language syntax
and
and
like how
semantics and all that whatnot.
yeah, exactly. Semantics and semiotics and
Yeah, but like you know, just like one of those things. I remember like when they were talking about like when in linguistics courses, you'd do um like the kind of like the parsing trees where you would like break down sentences.
Mhm.
Did you ever do that? Where you would like draw like these little lines to like break down a sentence into its like constituent parts, like these two words
Yeah,
go
I did
together.
that in like Intro to Linguistics.
Oh, I hated that stuff.
Mm-hmm. But like it's like programming languages are like it's like that, but designed to be completely unambiguous, right? Whereas like when you did that in linguistics for natural language, it's like there's
It's like
ambiguity.
yeah, it's like an attempt at yeah. And here we go. We're talking about language in the lecture now.
Mm-hmm.
Blah blah blah. Blah blah blah. Okay.
I only took the intro to linguistics course, but I found language and linguistics a pretty fascinating topic overall, especially when I was like a
right
senior in
here.
high school and
The
freshman
first
in
part, we're
college.
going to
Yeah.
For a while there, I was, I like
It's like
reading
it's
about it a
kind of
lot.
interesting how much it ties into like everything, and it's not something that people think about a lot. That does tie into like so much.
Mm-hmm.
come
Yeah,
to
even
this
here,
and
you
say,
actually, this is a good example of like when they like in language they can teach you about valid syntax, but
Hmm.
semantically invalid, like sentences that have the correct order and words in it, but semantically meaningless.
I think I missed something. Does not make sense. Syntactically valid, not legal. There's a string.
second is a string. It's a sequence of characters enclosed in double quotes.
Okay, a string followed by a number. It's not a legal expression.
Followed by number. It's not a legal expression. On the other hand, as we'll see in a second, this is a syntactically valid expression. It consists of a number, an
Yeah,
operator, and a number. So we're going
not
to talk
mute.
about how do we put together legal expressions. What is the syntax of those, both in terms of simple combinations like this and how we do it when we get to more complex aspects of the language. Associated with every expression that is syntactically valid is potentially a meaning, the semantics. What does this expression evaluate to? And here we're going to separate
Static semantics and full
out
semantics.
both static semantics and full semantics. Static semantics tells us which syntactically valid strings actually have a meaning. In English, in bad English, the sentence, I are hungry, is not actually meaningful. It's syntactically valid, meaning it's put together properly.
The danger is having people
pronoun,
feed
a
answers to
verb.
you.
This guy is making me so sleepy. Yeah, he's pretty soothing. Why do you think I'm doing this time? Just trying to make myself go to sleep.
And then an adjective. Perfectly legal combination, but semantically it doesn't make sense. Same thing happens in a programming language. The first expression, 3.2
I
times
feel like it
5,
goes slowly because
is
it's like
syntactically valid.
I don't know.
The
The
second
concepts
one,
are kind of
I
pretty
kind of feel
basic
like
still.
this is like there's a lot of stuff that people who are maybe like more interested in computer science or related fields would kind of understand intuitively, but it's almost like broken down for someone who wouldn't have that kind of intuitive understanding. But I don't know. Yeah, I don't know if that's the right way to go about things. Okay, gonna start building this up. Semantics is the meaning associated with that syntactically correct string of symbols with no semantic errors.
Yeah, I mean, like just talking. I mean, like just talking about semantics and valid syntax and all that stuff. It's like it could easily be skipped over in a course, but like, and you're right that like people who are kind of who find programming intuitive, I think it would be, or who are interested in computer science, it might be kind of intuitive for them to begin with to understand the difference between like semantics and syntax and static like syntax and that type of problem. But yeah, I think it makes sense that if you don't know where people are coming from, because like the course, I think if you look at the course prereqs, it says that anyone who has like high school level algebra or something can take has like enough knowledge. So I mean, if it's truly as someone who's never given this any thought, yeah. So like, if you've literally never given any thought to this stuff and you haven't taken a linguistics course,
Yeah, and
then
this
it's
kind of
like,
this is kind of like what I feel like Beaton was talking about this too, where it's like, and he was referring to math, like being able to like problem solve in that way, but it's more just like thinking about like how like in a programming language, like how to weave together different actions or something that is maybe more inherently related to linguistics somehow. Anyways.
right. I mean, you spend a lot of time in a linguistics course learning things that have almost zero application to programming.
Semantically correct,
Like morphology and syntax. I mean, morphology and phonology and like phonemes and allophones and all that crap is just like completely useless. But it's mostly just when you talk about syntax, like just knowing what syntax and semantics are is like basically enough to be like, oh, this makes sense.
And what's the semantics, the meanings associated.
I'm almost at the end of this lecture. What's the syntax? What's the semantics? Oh yeah, the audio will be like not synced for you guys. But I guess you probably muted the stream.
I big muted that.
What's the syntax of putting things on a talk about?
I actually really like this slide where they talk
Syntax of putting
about
things together,
the difference
what's the
between
semantics, the meanings associated.
like getting something wrong
With those three things
in a static way and getting something semantically wrong in a way that causes the program to be wrong.
I'm gonna scroll back up to his semantic error.
Yeah, the easy problems are the semicolons, like right. This third bullet, the semantic but different meaning what the programmer intended, is like, okay, that's the real killer.
That's the thing where it's like this reading lamp hasn't uttered a word.
Yes.
That's the thing.
Well, programs, it's never that type of ambiguity. It's usually just like a mistaken understanding. In the English example, is kind of like a semantic problem.
Well, it's like knowing like how knowing how flexible like a word is. I feel like.
I mean, they come in programming. It comes more down to either just straight up typos or B It's like misunderstanding a word. Like you
what it does, yeah.
There's nothing unambiguous. There's nothing. Programming language is designed to be unambiguous, so you won't get the situation where that type of sentence can be interpreted more than one way. Everything in a language can only be interpreted one way. It's just
it's like user error, user interpretation error.
You use the wrong word because you misunderstood the word. It's like when people speak English and they say, I don't know. It's like, I was actually about to say intensive purposes is the perfect example of like. That's the type of thing that goes wrong in programming languages. Intensive purposes.
Yeah.
It doesn't have another meaning. It's just you misunderstood what you read or heard, and then you wrote it
I
in the
definitely
program.
say
Intensive purposes.
Yes.
I definitely say intensive purposes like a third of the time.
For all intensive purposes, that's the bulk of problems in programming.
Okay, I think I've gotten what I had gotten out of this lecture.
I mean, honestly, I think that with the
Hell yeah.
first few couple of lectures, it's like almost like the type of thing where you could probably just take the quizzes and be like, read the answers and probably be like, I think this is probably the answer because if you
Okay,
know,
determines whether a string is legal. Let's say syntax. String has meaning, semantics. No, static semantics. That's my guess. Perfect. Easy money.
Easy.
Yeah, let's do these next couple of quizzes. Let's see if I can do these. What? For each of these following expressions. Okay, so there was some stuff in
oh, this is. I think this is actually getting into
this
the.
is actually getting into it a bit.
Yeah, this is actually now. It might actually be time to watch the lecture because this is actually getting into.
Oh my.
That's why I said it. It doesn't take that
Now that
long.
we have
Like
that idea,
I remember going.
wanna put
Yeah,
together
well, it doesn't
point
take that, but it's like 4
the
videos,
primitives
but they're all
Yeah,
like
that's just-
ways
10 to
we can
12
take
minutes
up that
long.
idea of how to use that
Yeah,
system.
that's what I was saying. Is that when I did this new show, I was like, yeah, okay, yeah. So there's like four. There's like
So
some
let's talk
period of
about
time where they just
Python.
set up the foundation, but then
Python
pretty
being the
quickly they're
language we're going to
like
use
telling
in this
you
class to do
about
programming.
types. And I do think that like a lot of programming courses just throw you into the thick of it, and they're like, this is how you write a hello
Yeah,
world. This is
yeah.
how you do this, and they don't actually spend any time being.
I feel like
this
most
is
intro to programming types things I've seen are kind of like that.
Yes.
Well,
it's trial by fire. It's like
Yeah.
throw you in and
And-
be like, this is how you do this, and they
Yeah.
don't tell you
the
what a type.
basics.
Yeah, they don't tell you what a type is. They don't tell you. It reminds me of dual.
Yeah, but I kind of almost agree with that more.
I don't know. What would you say, Brandon? Yeah. Yes.
Oh, Brandon's in here. I forgot that I have him muted. What's up, Brandon?
You haven't heard Brandon at all?
I haven't heard Brandon. I forgot that because
I feel like you've been responding to things.
I
though.
feel
really?
like he has too.
Maybe like you've been echoing your sentiments, and he's been like
Yeah.
responding directly to you. But like it's like one of those things where that's a really weird feeling. Where like
What?
where when you go back and think of the conversation, you're like trying to think, did he ever actually respond to anything Brandon said?
It's like a movie. It's like a movie
Yeah.
where the plot twist is that like Brandon was schizophrenic the whole time.
Like
Choi never existed. Why do you think everyone always? It's like Fight Club.
Yeah.
Dude, spoilers.
Oh my
Spoilers.
god. Oh
I've-
my god.
I've seen it.
Damn, I wish I had a slice of cake, Brian.
I don't have one anymore.
It's because you do have it still.
Hell yeah.
No, he can't have it in either.
He has its power.
Yeah, it's in you. You have it.
He's in you.
It's part of you now.
Man, I could get something sweet right now.
You know what it reminds me of? The Duolingo thing, where like Duolingo, they try to teach you by like completely by never explaining almost anything.
But it's like the thing is with like
Duolingo doesn't tell you what a conjugation is. It doesn't tell you.
What?
No, yeah, Duolingo literally just like basically wants you to learn basically 100% by drill.
I think but the thing
And
is, it's like they
they
expect
will
you
never
to.
even-
I think the expectation is that like you can grasp certain things intuitively. Like maybe
I
not
mean,
the details of conjugation, but like if you learn like this is how you say to the
Yeah, but
verbs.
You can't intuit programming from just trying.
Yeah, well that's like probably more to do with the fact that like Edgar was saying earlier, it's like programming languages are meant to be more or less like they can only be interpreted one way by the computer. And that's why there's probably a little more like rigor into understanding the fundamentals of it, because you can't it goes back to the third type of error. You can't have the user just misinterpreting things all the time.
I mean, I feel like the Duolingo thing, what it reminds me of is like Duolingo's like a really advanced phrase book where like you will learn sentences and maybe eventually you will pick it up, but I don't know. I've doubted at times
There has
that
to
it's
be a balance for adults.
yes, for adults. That's what I was saying. I was like,
Yeah.
children can learn by you throwing the language at them and them like basically parroting you for like 24/7 for like 5 years.
Yeah.
You know?
But
Then
so I kind of like a degree of that, of just kind of like throwing you in there. But yeah, you can't just Duolingo is too much, I think.
Duolingo is at best like a part of
Oh.
helping to learn a language, but I don't think it's complete. And I also think that about programming. Like if the course is basically just put you in front of a Python interpreter and like teach you a few things and then expect people to like learn programs by rote where you just like keep typing at the screen until you get the right thing. That's not how you get good programs.
Mm-hmm.
That's how you get bad programs because
it's so specific. It's so
really
specific.
frustrating.
yeah, it's really it's a part of frustration, which is actually maybe why Brandon was talking about the memes
It's
with
like the same way
semicolons.
people learn math. It's another math example.
Okay, now Brandon's
fucking
just not
hate
saying
math.
anything, and he's fucking with me.
I don't need to say anything.
What did you say, Brian?
I said it's kind of like how a lot of schools kind of teach math by just like throwing it at you and ignoring.
Concepts.
Yeah.
Yes. I mean,
And then people hate math.
yeah.
Yeah.
I agree with that. And it's like the people who intuit the math like it, but it's
Yeah.
only because they, for whatever lucky reason,
Yeah,
managed to see
basically they
under-
get lucky. Yeah.
Yeah.
If you're like if you don't have like an aptitude for math, you need like, and you don't have friends who are good at math or who are good
You
at
need, like, a
teaching
really good teacher.
math, you need like, you don't just need a really good teacher. You need like a chain of really good teachers. If you get a bad teacher at some point, you're fucked from then on.
Yeah.
It's like a problem.
I mean, the thing about programs being unambiguous doesn't mean. I think there's like a little bit of I don't know, it's a converse error in the sense that a program can only be interpreted one way, but there are an infinite number of ways to write a program. And so throwing people at at programming has the problem of this is how you end up with people in courses who like program by trial and error. Where like it's like the proverbial person who like debugs by changing random things in the program until it does what they want. And it's like that's the danger you get into if you teach things that way. So
Wait, I need to get through this lecture, guys.
yeah, sorry. This is what
Don't
happens.
stream lectures.
Stop
It's not a
talking
good
over his
idea.
music,
You need
I'm
to
teaching
do
him
that.
more important things.
I bet. I feel like it's like everything that's happened. Like, so Edgar was like telling me some stuff yesterday, and then I went back and I watched the first like 2 lectures, and I was like, this is like everything Edgar was telling me. Like,
You should deafen us while you watch the lecture.
oh
and
yeah,
ask
that's a good idea.
questions.
That way you guys can just like
Trash talk you.
yeah, you guys can just chat amongst yourselves, and then I can go back to it when I'm done with this.
Look at this idiot.
All right, here we go. Shell commands. This is what we're seeing. I missed something. Shell simply window. Commands or statements.
Primitives that represent data. Those we call objects. And programs manipulate data objects in order to get out parts of those objects or to do something with those objects. Every object has a type associated with it that tells us what kind of thing it is. And more importantly, that type That type is really important. That type.
Okay.
Finally, objects come either as scalars, which says they can't be subdivided, or if they're scalars, obviously non-scalars, which are things that have internal structure into which we can pull out parts. Let's start with the simplest version of these. Scalar objects in Python. There are very few of them. We have ints.
Okay, we have ints, integers, floats, a bool, and none type.
It's called none type. It's a very special one. It has only one value, which is none. We're going
Scalars, ints, floats, bools, none typed. And they cannot be subdivided. Okay.
to by using a built-in procedure called type.
Okay.
And I'm going to
Whoa.
skip down.
Whoa. Time to shrink this bad boy and open up my little guy maybe. Huh?
I'm now talking to a shell. And you'll notice it's got a little prompt that says in, saying what's the input you want to give. The fact it's got 30 on the machine is because I was doing some other work earlier. So this is going to be the 30th.
I like how this guy's like, I was just
And
doing
I'm
some
simply
other
going to
work
type
earlier.
in
Don't worry
the
about it.
number. And the output is the number itself.
What's
Well,
this
duh,
thing
you
not
say.
opening?
But it's actually important because what the machine did was it read in that sequence of characters, understood that it was a number, and the value.
Okay. Sometimes I want to change types.
Sometimes I want to change types, especially
Man,
with numbers.
my little guy is
This is
taking
called
a
casting.
long
I can
time to
cast
open
types
up.
of different forms. And you can see the example. If I say I want to take an int, such as 5, and turn it into a float, I can ask it to do so by giving
we
it
go.
the special command float, the thing contained within parentheses, and it converts it. The other direction also works. If I want to take a float, such as 3.9, and convert it into an int, here you say, boy, there might be some
What if I do
choices.
this?
Python
I'm curious.
simply gives the whole number part of it. It doesn't round
Okay.
it to the nearest
No
integer,
rounding.
as you might expect. If you want to build your own programming language, knock yourself out, you could do that. But it's simply
Okay.
3 plus 2. That has a value associated with it. And in fact, that expression is to take
Bam!
the 3 and the 2.
I'm just kidding. I'm curious what this does now.
And apply the arithmetic operation of addition to them. And I can type, for example, by saying print 3 plus 2.
Oh wait, I get it. It's
Huh.
what? I
A
get
little
it.
bit of
I
a
get
difference.
it. I don't
And
need
in
to do
fact, there's
this.
no out here because no value is returned. Print returns that none type and doesn't print anything out. It just printed something.
So
And so in the simple first case, the whole value of the computation was 3 plus 2 equals 5. It was printing out 5. In the second case, the side effect is to print something.
I get it. Object, operator, object. Okay.
What would those expressions look like?
Cool.
Well, here's the first set of them.
Oh, God, this play
There's
button.
a lot on this slide.
So these give ints unless there's floats involved. This gives always a float. Int division. Quotient the remainder. That's an interesting one. So what happens with the exponents? Percent gives the remainder? Interesting. Cool. Doesn't tell me the type. I guess it's the same thing where it's like if it's all ints, we're ints. Okay. Parentheses. Order of operations. Wow, order of operations. Glad that remained the same. Okay, cool. Lecture done. Let's go to this exercise. That's a float. Int bool float. Yeah. Oh, whoops. None. The Python none keyword. None type. Bam. Wham bam. Super slam. Oh wait, I can undeafen myself now.
Yeah, I haven't used that in a really long time.
Alright, I'm
All
back.
right, Cho's back.
You got him right. He knows a float.
Woo!
He knows an int. All right, he's
One of the
ready.
photos.
He's
Look
going
at
for
this. Look at this.
now.
I went from one, I did a lecture. Now 2 exercises.
Oh,
Oh boy, here we go.
not time to teach him about the binary representation of a float.
For each of the following expressions, indicate the value returned.
All right, let's watch. It's like doing arithmetic.
Yeah. This is why it's stressful because
Literally order of operations.
I can't get
Yeah.
anything wrong here because then you guys will make fun of me.
No, I'm terrible at that.
Estimated time to complete 5 minutes. I
This
think you should
has-
spend less time talking
This
to
has
us.
to be error, right? This has to be error or something. I don't know. 10 divided by 3 would give me whoops, no, not that.
Every year.
Every year.
Like I don't know what 10 divided by 3 would give me.
That sounds like a Spanish verb. The past tense,
Did
I
they explain
RL.
integer division in the
They did.
slides? Okay.
They told.
Yeah.
They mentioned integer division.
I think this
That's
is
all
gonna
it's
be
on.
this. I don't know like how long it. Well, I'm pretty sure it will look like this. I'm just gonna try it out. 'Cause
Are you
I'm-
sure in the instructions it doesn't say how many sig figs to use in case
Oh,
of
okay. It doesn't. Yeah, it didn't. Maybe it did tell me in the. No, it doesn't tell me here. It might have told me in the lecture somewhere. But I'm pretty happy with what I did so far. Okay, what's this? 20?
Decimal answers give the full result or 4 decimal places.
Oh, you only have to go to 4.
I just saw it.
Oh, really?
Yeah, you only have to go to 4.
Okay,
decimals.
okay.
RTFM, dude.
Oh my
You
gosh.
didn't read the beginning of these.
I'm like, it's 9,
Whichever's shortest. Nice.
2.1 squared. I feel like I know this, but I don't want to guess.
Why is it a feeling?
I feel like the order of
I
operations.
knew it was
thing-
441. Okay.
I feel like to help myself with the order of operations thing, and also, I mean, not with as a kid. As a kid, I never really find it particularly annoying to memorize like the PEMDAS crap, like please excuse my dear Aunt Sally.
Yeah, I mean, as you get older, you just
Oh
realize what operations
my
actually mean, and
God.
you like simplify it, or not simplify, but if you expand the actual expression, you're like, oh, that makes a lot of sense.
Oh, it just gives me 4. Okay. That's cool,
Yeah,
I guess.
it's -4.
Oh, that makes sense. Okay. Well, I guess I should have not skipped around the lecture.
The tricky thing about the minus operator is that it is simultaneously a unary operator and a binary
Yeah,
operator.
okay.
So that's why it's confusing. People forget that the dash can be used as minus or negation.
So that's kind of a trick question almost.
Yeah. I mean, it's important. I think I like the question because it's actually kind of an exception and I think it's generally bad practice, but they do it because it's how people are taught math in general. But as a programming principle, I think that you probably want to avoid operators that have
Two
like
uses.
that have like uses that are confusing like that.
You're gonna run into some dumb shit too, so you got to be able to spot it.
Yeah, basically.
Okay.
Oh, but like
Below.
I remember thinking later because I was thinking about order operations and programming, but I also realized that like the order actually there is a method to the madness that like it's not completely arbitrary that the order of operations is that the priority takes the place from the most abstract
From
to
the
the
most,
least abstract.
I think of it more like the most extreme to the least extreme.
Well, no, but I mean, like, what I mean by most abstract is that every time you get taught a new pair of operations in arithmetic, you're learning something that's an abstraction of the
Like how
former.
multiplication's like addition over and over
Multiplication is just
again,
addition and stuff
and
like that. Yeah.
exponentiation is yeah.
No,
That's
but I
like
mean,
that's what I was thinking, but I don't think about that in terms of like abstraction. But I guess
well, I
that
mean,
makes sense too.
it's literally the prior
Except
operation
for parentheses.
done multiple times, right?
Uh huh.
Like
Yeah.
multiplication is just add this to itself n times.
Oh my
Yeah.
God. This is what Brandon and I already said.
Oh
Yeah,
yeah.
we like talked about this.
Oh yeah.
Jeez. I'm just kidding. So I feel like I can guess most of this.
Right.
I feel like, and then when I with programs, I took that, and then on
Oh
top
yeah.
of order operations, I'm like, oh, okay. Operators generally have precedence in order of unary, binary, ternary,
Wait, actually, I don't know.
and beyond that, I use parentheses basically. I don't like to rely on like whether equals equals has priority over and. I mean, some people do, but
Oh yeah.
at some point, I just go to parentheses between anything even remotely nearby each other in the
Readability is the most important thing.
yeah.
I'm gonna guess here.
Oh, you've
No!
gotten
I got bodied. Okay, gotta watch the lecture now.
I got by.
Wait, just try again.
So we've now
If you
seen
can do it.
Brian doesn't want you to doesn't want you to skip lecture.
You weren't that far off.
Oh my God.
Just keep going.
Okay,
Brian's like,
A equals A.
this is funnier.
Is this gonna give
Brian-
me? This is not gonna give me none type. This is
Brian's
probably gonna
compromised
give
your
me.
education for his own his own entertainment.
I think working through problems is better than watching a lecture anyway.
I mean, it depends. I would at least encourage to like.
Yeah.
I don't know if they do this easily, but to click through the slides.
Yeah, that's yeah. They don't really have that functionality.
But it's
A
like I think you
equals-
could probably figure out most of it by just clicking through the slides and not having to listen to him talk through
Yeah.
it at like a slow pace.
I'm pretty sure. Okay, so I did get that right, and then my guess is it's gonna be something like this. What?
All right, maybe watch the slides.
Oh my God! I'm deafening you guys.
primitives.
This stuff I kind of figured out, or like I probably have learned before, honestly. Um, Blah, blah, blah. Incrementing. This is what...
That expression, adding 1 to something, it's something we're going to do a lot.
Okay, I think I have to reread the instructions. Because I'm like doing this wrong. No. A equals 3. I fucked up. Okay. Okay, I figured it out. I forgot that these were all like supposed to be combined.
There you go.
Yeah. Oh yeah. See, it does say assume the expressions are evaluated in the
In
order
order
shown.
shown,
Well,
yeah,
Troy just
exactly.
doesn't read
I just didn't read these.
instructions.
I realized like as I started the video, I was like,
I feel like
Exercise
the first paragraph seems important too. What does it say? Provide the.
You don't have to watch the lectures, but read the instructions.
yeah, okay. For each of the following expressions, indicate the value returned, or if the evaluation will lead to an error. Write the word
Just try
error.
it.
Oh my god, I need to read these instructions for real. Okay.
IDE. Where's the Vim lesson?
Python. It's Python. It's fucking interpreter. Open it.
I think they're confusing IDE because the IDE has
My guess is
the
like
interpreter built
I just
in.
want to
It has
make
a-
sure I'm going the right direction. I think this is going to be like, is this going to spit out false, right? Yeah, okay, cool.
So one of the previous things, I don't remember if it was the original like 2.5 or whatever. It was calling the interpreter IDE, and I was like, what's going on here?
Yeah, I don't like the conflation that they do sometimes, where
Whoops.
they're not telling people that the interpreter is its own thing that is only being included in the IDE screens. So to call the interpreter the IDE is just like one of those things where it's like,
It's like
wish you
you're
wouldn't do that.
giving people misunderstandings about what words mean for like no real benefit other than just showing them fewer words.
Semantics are important
Yeah.
in CS.
Yeah. Right, yeah, like what's the benefit? Like, oh, they know what window to switch to. You didn't bother to explain to them that the interpreter is a program that's being run within the IDE. I mean, to make things more complicated, this one doesn't even use the interpreter, it's like the vanilla interpreter. I saw Troy using it in its IPython, which is good because it's like an enhanced interpreter, but it's also not like the.
It's not real.
It's I don't want to say not real. It's just not the base one that comes with. So
Yeah.
you might like.
What am I doing wrong?
Oh.
Is it the 2 + 2 equals?
No, I'm just saying like, what are you guys talking about?
Oh no! So
criticizing the lecture.
Oh, okay.
it tells you to type it that you could type it into the IDE, and the term IDE there is being used a little loosely.
What? I have no idea what happens if I write this. Does it just return error? Yeah, it's probably got to return error. That's a valid answer. Probably error. Probably error. Do exclamation marks? What do exclamation marks mean?
Yeah, so like this one where it's got the minus in the exclamation equals. It's like I would use parentheses there while we're writing that code.
Also on that one above with the equals and the addition, like.
What is okay? Well, I have to go back and ask questions about these.
Yeah, I mean, if you want,
Dude, 3 is not more than 4. This I know.
Thanks. Good work.
Thanks, man. I'm a physics major, if you couldn't tell.
I think it's true.
I couldn't. Never mind.
It's false. Let's see how I did.
It's more intuitively obvious when it's word operations and symbol operations combined for some reason.
So Troy, I would encourage, in general, in programming, to like.
Oh,
It's like
I get it.
it's like the
do,
thing.
do you know about logical OR?
Yeah, do they teach logical operations?
A little bit, and I just
You might
uh,
have skimmed it too quickly.
I was just thinking about it, not dum, but
You're thinking about it like a normal person. Or in everyday English language is exclusive or.
No. I think that what's more accurate to what it's saying is that he wasn't thinking of or as a mathematical operator. He thought that it was semantically like invalid.
yeah, I forgot that it was like I forgot that we were talking like yeah. I
That
forgot
or
that
is a math
we're
thing.
moving to yeah, exactly.
Like zero or false or false might as well always be
And then
zero.
it's funny because at the
Zero.
end I like was like, oh wait, no, I understand
Yeah,
now.
you so that's kind of weird, but yeah.
And then but then I just forgot to go back and like look at these. Does this mean like equivalent statements or something?
Which
This
one?
exclamation mark equals?
Exclamation equals is the not equals sign.
Oh, okay.
It's the inverse of equals equals.
Okay.
You can only mess up this quiz once.
Wait, fuck.
It lets you take it twice.
That's not very
It's free.
great. I'm auditing this class, bro.
Oh.
Exercise 9. Okay, below the transcript. For each
I just encourage in general to like try and think of expressions, like evaluate them in your head like the computer would, which is defined. Like to do the PEMDAS in your head, basically, to find the expressions that are evaluated first, and then mentally in your head replace the result with, like if
Don't
there's,
try to do it all at once.
yeah, like if there's a 3 less than 4 in there, then mentally replace it in your head with true, and then you continue to evaluate the expression.
I think that's basically what I was doing.
Mm-hmm.
If I think
Some people I feel like they have a hard time doing that.
they try to do it like step by step, like one at a time.
or left,
And then
they
they're
do
like,
it left to right.
and they're like, wait, was that an or at the beginning? Or I get what you're saying. Yeah.
Like sometimes I don't usually take out paper to do this because it's usually not that complicated. If someone writes code, we need to take out a piece of paper to do it. But like
So
at the beginning, it can be helpful to do it like paper, like you're doing math in school, where it's like 3 + 1 + 1, and then you do 4 + 1 equals. And
what's the difference between double equal sign and regular equal sign?
Equals is assignment, double equal is Boolean.
Oh, okay.
Yeah,
Yes.
so the double equals is basically a mathematical operator, and the single equals is like the special assignment thing.
I see what
Yes.
you're saying. That
Yes, equals is a Boolean operator like or and not.
Okay.
Basically.
Less than, greater than.
What?
Yeah. They take in 2 inputs and return a Boolean value.
Oh, I fucked up. I got tricked. So hard. In my head, I just like read this. I was like, and then I was like, oh wait.
Oh, I
These. Oh my god.
Oh, they're directly testing your understanding of equals versus equal.
Yeah.
Mm-hmm.
I fell for one of the classic blunders.
Yeah, basically.
You didn't fall for the trick they wanted you to fall for, though.
Yeah. Yeah, you fell for the fact that you didn't see the A at the end, right?
Yeah.
It's a little bit of a weird way for them to state the question to like they're writing what you would write in the interpreter. But I think a normal test would just be like, what is A after these 2 lines above or something like that.
Oh, this is like a synthesis of everything or something. Yeah, it is. Okay, cool.
A synthesis.
Type of expression, value returned.
It's like I should say former manager because I got switched manager, but he liked to use the word multiplicity. And I was like, some people have words. I guess I have words.
You have words.
You have words for sure. Everybody has words.
Yeah.
Did someone
I like
Did someone say nuances?
I
He starts giggling.
I can't help it. That's been such a long running joke that it's so loaded for me.
Does
Basically,
everybody know the origin of that joke?
I
Or
don't
is it
think
like-
so.
It's
or
been
is it like
explained.
Stan? Everybody just uses it now.
It's been explained, but I don't remember it.
It's the Kevin, the Gil Glowy story.
Yeah.
It's a good story. But I just can't. I can't even use the word like sincerely anymore. I feel like it's very hard to like not say it and then snicker.
I definitely use it like Stan, in the
Mhm.
sense that I don't really know the story.
I like the word orthogonal. I think I use trivial more.
Oh,
than most people.
I feel like you use orthogonal
I
a
use
lot.
trivial and non-trivial. I use non-trivial a shit ton. It's like one of my favorite. It's such a good word. It's one of my favorite words.
I think non-trivial is a really great word.
It's a useful word.
It's like on the scale of not important to important. If important is not
It's enough to be relevant. It's
Yeah.
enough to know. You should know this.
It's like those have a magnitude of 1, and trivial has a magnitude of like 0.5, right? Like it's not important, but it's
As a non-trivial contribution to any conversation.
Non-trivial is like Luigi misfire. You should.
Yeah.
You gotta take it into account.
I think.
I like orthogonal too, though.
Yeah,
I mean,
you
people
definitely
really
use
great
you
one.
definitely use orthogonal a lot. I feel
Orthogonal
like.
is really good.
Well, I think
I should use it more.
people.
I use tangential a lot,
Yeah, that's what I was actually about to say. It. People
I think
use
orthogonal
tangent.
is better.
but I should use orthogonal.
Yeah.
They're
Whatever
like
you want.
totally opposite.
Orthogonal.
I think
yeah,
the thing is like people kind of use them similarly because it's like
yeah,
when people
they
think
definitely
of
know. Like, they
orthogonal,
absolutely do.
they think of the fact that like an orthogonal line is
I mean,
like
I do. I feel like I do use tangentially when things are tangential. Like something is
Well, like the key part
related barely,
of
but I also
orthogonal
just
is like orthogonal lines share no component.
tangential is you are relating something.
They relate
Like something is
Right.
touching this concept.
Yeah.
Well, it's a layman's term. I mean, I think it's like fancy. It's used in normal speech, and the analogy is pretty good because it
I think
like
a lot of
usually
people
is
know
referring to.
tangential, like Stan. I don't think
Something-
a lot of people know what tangents are.
But like people use it in a way that's very analogous. Tangent line actually is because you're having a conversation and there's an offshoot where they share some point in time, but you've kind of gone
Yeah,
down
like
a
tangential.
done a tangent.
is round a thing.
But orthogonal is
I
something
feel like I
that
actually just don't run into orthogonal a lot because I don't bring things up out of nowhere and then say that it's coming out of nowhere.
well, no, but when people are talking about issues, like a lot of times people will bring up two different things, and you can be, well, that's an orthogonal issue, and that happens all the time. Like you're talking about something, and someone brings up something else, and you're like, well, this is orthogonal to what we're talking. Like in argumentation, it's very common, or in conversation in general, it's like people. They're not going on tangents. They're like naming something that's like relevant, but just it's a different variable, right? And that's a different use of
it's really useful in arguments. I see. Yeah, for sure.
because like you don't want to say that like yes, it's a variable. There's x and there's y, but you're talking about something completely different to what is the problem currently at hand, or at least the facet of the problem. Did you just figure out what round was without?
No, I typed it into the thing because I assumed it worked, and I just wanted to verify they weren't like trying to trick me with something that the guy mentions in the lecture once.
Dude, general voice chat is going nuts right now.
Do you think he wears the same
Oh, gee, I
shirt
can't, James. I
in
can't hear
every
you.
lecture video?
I don't know, like maybe he recorded it all at once.
It's a common shirt. He probably has 5 of these shirts.
That's true.
Maybe he's like subtly changing the color every time.
You know, you can't tell from video to video, from beginning to end.
He starts off with like complete like dark blue, and by the end it's like completely white.
Yeah, see, Troy's in the thick of it
Be a
now.
good
There's like
bit.
control. There's like loops and bindings and right hand sides and left hand sides.
We had a couple things here. Let's just go right to the exercises.
Oh my god.
Do it. I'm down. I can watch you.
Show
do
is only in
exercises.
4 Discord servers.
I have no idea.
That's insane to me.
Oh,
Oh my
I have no idea what these
These
are
ought to
gonna
be
be.
good.
Oh, these are good. You can do these.
No hints. No hints.
Oh, okay.
Oh
No
gosh,
spoilers, bro.
I'm like, I have no idea.
Maybe you should watch this one.
Oh my
You should-
god.
I feel like this isn't super intuitive. I think you should go watch these.
Okay,
There's a
okay.
good sign that you should watch the video. It's probably when you look at the quiz and say,
You're like, what is this?
I don't understand the
Welcome
question.
back to 600 part 1.
Okay.
Oh, okay. Just,
Blah blah blah. We're going to go back.
ooh, branching and iteration, baby.
Wait, I have
this
to.
is
These are like important concepts.
yeah.
You should watch
This
this video.
is juicy stuff. It's not just like
Yeah.
I would,
First
I have
it's
to.
lecture,
not just
we
like
started
relearning
I have
that
to
1 plus
deafen you
1 is in
guys.
programming.
thinking.
I'm
And we
deafening.
began to introduce simple
All right.
expressions and very simple programs. In this lecture, we're going to add a new type. We're going to go back and look at branching as a key element in order to make decisions in algorithms. And then we're going to start introducing the first class of algorithms that are going to be really valuable, things called iteration or iterative algorithms. First of all, variables, often called bindings. These were names that we had to which we could associate values. And we saw they were created by using a name followed by an equal sign, followed by an expression that had a value. Why did we want the name? It could be descriptive. It tells us what that value is. One of the things to remind you is there are certain words that cannot be used as variables. These are things called keywords, things like int or float. They describe a type. They cannot be used as a name for a variable. There's a set of these that we'll talk about as we go through. And you'll notice in Python, when you type one of these keywords in, it'll show up in a different color, which is a hint that it's a keyword and not something you should be trying to do with a name. By reassign, is just the int2. We then store it. Sometimes we refer to that as bind it. To the left-hand side, which is the variable name, that creates a binding off in the machine of x associated with 2. But of course, we can also replace it with a new value. And here, again, if you look at the second expression, remember, we first evaluate that expression. That associates the variable. This is going to be 5, which is the value associated with y. Equal sign does the assignment. It creates those bindings. The second expression, signs. Suppose I got two variables named x and y, and I want to swap their values. The little sequence of expressions here looks like it should do the right thing, right? Wrong. Let's think about it. The first expression assigns x the value 1.
This is easy.
So far, we've just been playing with numbers.
Strings.
Can give the name hi to the string HELLO space THERE double quote.
Okay. Strings. Quotation marks.
We want to use an apostrophe somewhere in a string, because from Python. And so, for example, if I want to say foo is, this isn't, right? Notice that the single quote does
Foo
not get interpreted as the end of a quote.
equals this
Put
isn't
out the
right.
value of foo. Once I've got
Ah, it's interesting.
and when I print out greet, sorry, if I type properly, it would help. Print out greet.
Okay. Okie dokie. Put them together. Okay. Concatenate. That's a word. Oh my. Oh wait, does it actually say that? No, it does just glue them together. It does not say Varick.
But it said, hello, Theric.
Okay, cool.
So if I type 3 times the string
Okay.
Eric, I get an echo.
Okay. Is it saying Eric, 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 or rice, rice, Rick? Food for thought.
I can ask for the length.
Length. Okay.
String?
LEN for length. Cool. Okay.
Strings have things inside of them. They're the first version of a non-scalar object in that I can get out pieces. And one of the ways I can do it is say I can index into it. So if I take the string Eric and I want to get out the first element in square brackets, I can say give me the first element and it gives me R. Wait a minute. That's not the first element.
Because the first number is 0.
If I try and index beyond the length -1 of a string, I'm going to get an error. And that's because I start at 0. So even though this is of length 4, if I take the string Eric.
Cool. Alright, I'm ready. Okay, I'm back.
So
I'm ready.
Do you
That's
know
like-
how to code now?
Yeah, I'm
he
dev
knows
now.
He knows how to concatenate now.
Yeah.
Show us what the fruits of your labor.
This is totally the I know kung fu moment. Show me. we're all Morpheus and Troy's Neo.
How do you feel, Neo?
Yeah.
I know kung fu.
You believe the code you're typing is real?
I'm gonna guess.
Dude, do the Zoomers even know the Matrix? Is that one of those things?
I'm gonna
I
guess.
feel like they don't. And
Dude,
They
I
know
feel like
Stan.
they don't. I feel like they don't. You're right.
That's what I'm talking about. I was having this conversation with Wine, and I was like, dude,
Ooh,
Eminem's
ah,
band is
damn
Matrix
it.
era. Like, how will they know?
My guesses were wrong.
My guesses were wrong.
Wait.
Did you watch the lecture? Are you
I
sure
did.
you watched the lecture?
Oh, he just didn't. He didn't grok the slicing.
I didn't.
He got one of the
Of
slides.
course.
I didn't.
That's
I gotta go
that's
back.
still annoying for me. I kind of still am not intuitively good at that.
Slicing is inclusive to exclusive, I think.
Yeah.
Yeah.
That's
It's
the
like
most.
that's like consistent across languages too, surprisingly. It's like always inclusive to exclusive. It's surprising.
Slice a string apart. Here we go.
Honestly, you can use a for
And so I
loop
can
and
slice
create
a
2 slices or something.
string apart by giving it a somewhat
I
funky
feel about that
name,
one
right?
so
Take Eric,
regularly.
And again, in those square
Well,
braces,
I
give
still
it
like
a
it
starting
because
point,
the
which is one,
nice about making the
colon,
end
and then an ending point. In this case,
exclusive.
3, and it gives
Exclusive
me
is length.
the first and
Yes.
second.
Yeah.
Is that? Yes.
Inclusive,
Zero,
then exclusive.
yeah,
Yeah.
zero. If you go 0 to 10, you get 10 characters because it didn't include the last one.
So,
This is true across like
Okay.
almost
so
any
it's
language.
including up to 2,
I guess
and
the
this
way,
is
the way you
also
remember
including
that,
up to
I guess
2.
this is reiterating what we just said, is if you did 0
Perfect.
to the length of the string, you're going to get the whole string.
I mean, people did a really good graphic once, where like explaining, and I wish they showed it here when doing the splicing, where if you imagine the beginning, the end, it's like posts. There's the start post and the end post.
These are ungraded.
And in a 0 indexed array, if you go to 5, you're going to get everything from between 0 and 5.
Look at all these people.
But you don't get the 5th. You don't get the. You don't actually get the character that's at the index 5.
All these people asking other fellow students questions, and I have like a personal dev team.
But like,
Spoiler exercise.
How to solve this?
Spoiler exercise 2, part 4. What the fuck is that?
Wait, how many years of developer experience are in this chat? It's like
almost
18, right?
something like that. Do I count when I wrote C in the 8th grade?
Okay.
you done?
No, I mean,
Cincinnati?
I think the whole indexing inclusive to exclusive just fits in with the whole index philosophy. I think it
Yeah.
just makes
Makes
sense.
sense.
Which is why Brandon, like what you said, why it's so consistent. I think it just fits the paradigm of zero indexing, and
Yeah, the languages are dumb, so it still surprises me. Everything is consistent.
yeah, there's some arbitrary differences where you like kind of like anything could go wrong if they did this.
Or like the
Um,
engineering or like
Fuck.
mathematical
I
languages.
got bodied.
Like one index.
You watch
Yeah.
this lecture.
I got bodied.
There isn't a lecture.
Oh, I don't know what to tell you, dude. You should Google.
Oh
Damn,
no,
you got fucked up.
the lecture probably covered this, and I just completely ignored it. It's probably
Wait, there were two videos. Did you watch them both?
yeah, I did watch both of them. I
Are
thought
you
for
watching these at like 2 times speed? Like,
STR.
do they just feel long when I have
Oh,
to?
I
Troy,
I fucked
I'm
up. I figured it out.
I'm just gonna go ahead and tell you.
I figured it out. I was just
Well,
not thinking.
Wait, no, let him. He said he figured it out.
You
Let him
guys
do
are
it.
distracting me.
Mhm.
Yeah, we're not.
I mean, you're the one who decided to stream this, so I just feel like you knew this was probably not going to be always a net positive on your educational experience.
Holy shit!
It's okay. I still don't know what to do for this one.
Which one?
STR1 minus 1. I thought that didn't work for some reason.
It doesn't in most languages, but in
It works
Python
in
it does.
Python. It works. It
Oh.
works in Python.
So this was in the video.
Do you
And
want a spoiler?
You can
Yeah.
fuck around with it now in the interpreter. I mean, like,
Yeah, let's just see it.
Oh, that's a smart
that's the
thing.
beautiful thing about Python. Whenever, like, just open the interpreter. It's super easy and just fuck around it and just see what it does.
Okay.
Yeah, but rather than us telling you, it's probably more instructive to bring up the interpreter.
And then see what it outputs.
Mm-hmm.
Oh.
So it's
It goes- it just
STR.
It just loops back. Cool.
Mm-hmm.
Now, why does it loop back?
Because
Also,
something in Python does.
well, the goalpost like graphic I was describing earlier is also nice because then they did this thing where like, well, if you mirror the string the other direction, then the -1 is really accurate too. So like, if you visualize that in your head, then even something like -1 to 1 could make sense, right?
Interesting.
The length is 5, which puts me at. I think this is what I was thinking of.
Corbin used to see it.
Are you guys typing shit about me?
No. No.
Oh, okay.
That's
Who would see it?
right there, dude. Yikes, dude.
We're DMing each other stuff.
Oh god.
Oh, and you're gonna play it on stream? You can play it on stream. I don't think it's bad.
Oh god, I'm not
It's
playing
a
that
fan.
on stream.
It's really funny.
You can get Troy kicked
It's
out.
pretty funny.
it's stupidly funny.
Hey, what are these notes? Have you tried clicking on the note?
What?
Click on the blue text.
Is that a knock?
Oh,
Oh,
No.
no.
Advanced string slicing, note the Python in operator. These seem like useful things to click.
wait, yeah, what?
Oh.
That's a life.
These are very helpful.
Am I behind the stream?
The
I feel
stream,
like
the stream's a little
never-
slow.
In my life, have I encountered negative indexing in Python in like production?
Really?
Yeah, I feel like I've never run into it.
It's really useful.
I learned it. I learned it
Really?
in school. I just
Yeah.
haven't run into
I
it.
see it.
All right. Okay. Here's an example. You have a string that you know ends in .exe. What's the shortest way for clipping off .exe? String brackets colon -4.
Maybe I just don't do a lot of string manipulation.
Yeah. That's why.
That's probably the more likely answer. I just haven't had to run into.
I run a ton of web scrapers, so I use that type of thing pretty regularly.
Like otherwise, you have to write like len minus something, which is fine because that's what it's basically short for, right? Like -1 is just shorthand for len -1. But as you can imagine, indexing relative to the length of the actually, I mean, I really think that's like one of my favorite things about Python is that they saw this and they're like, well, one of the first things that you want to do.
But if we just make life a little easier right here.
Yeah, is that it's going to be very common to want to index relative to the length of it. So
I'm just gonna try it.
Right, so like you could write minus, like if you wanted to get if you knew it had a 3-letter extension, you could write -3 to -1, or is that how you know it would be uninclusive? So you might have to do.
It'd be -3. You can just do it to the end.
Yeah, to the end. Yeah. Yeah, you would just leave it blank.
Yeah.
So you can go minus, but you can't go more than. Is that what I'm getting here? Like if I have a string that's like 4.
Okay, on the interpreter, dude.
I did, and this is what I. Can you see the thing for me?
The interpreter shows nothing.
I can't see
how far behind is your stream?
Yeah.
No, I think it just might be off screen. I see
it's off screen, yeah.
Oh, then no, we can't.
I see
anything.
Spider, but I just don't see your interpreter.
Why is
Yeah, I see the spider. I just
maybe
don't
I
see
can
the...
I see Shea Captain.
Move it over a little bit. Can you see that?
No.
It didn't do anything.
There, keep going.
Is it possible if you just open IPython direct? Like pop it out in its own window or something?
So, I tried this, and that does not work. Yeah, so my intuition was correct.
Oh yeah.
Cool. What?
You should note that when slicing, it is actually allowed to go beyond the ends of it. I think it's just when you're indexing a single element. When you're indexing a single element, Python will complain if there's nothing actually there. But with slicing, you won't. I think.
Can you not drag that thing that says console 1A out into somewhere else?
Yeah, that's what I was saying. Can you pop it out? Sometimes IDEs have like a little pop out button to pop a window out.
Good night, fam.
Good night. Open an IPython console. Nope. Can't try.
What IDE? Spider is the name of the IDE.
I think Spider is more than. I mean, it's like. I mean, I think it is an IDE. It might be one that's like.
Does the Windows Linux subsystem shenanigans have Python? You can just install.
I was gonna say you could use Replit.
Maybe. Oh, you're talking about WSL? He doesn't probably have WSL.
What?
It can't be that hard to run Python in Windows.
No. Install Python for Windows.
Yeah, just install Python. I would just install Python.
Yeah, I know they had them install. Well, I mean, if you just hit start and you type in Python, what comes up? Did it not install like Python as just a straight up interpreter?
This is like this.
Idle or Python command line will work too.
This guy?
Yeah, try it.
This is the old version I have, 2.5.4. I still haven't, I gotta uninstall that.
I see.
You could just install Python through whatever.
It told me to go through this thing, the Anaconda Navigator.
I think the Microsoft Store even has Python now. Like you can install through the store. Yeah, look, Python 3.7. Even the beta can be installed through the Microsoft Store.
Yeah, dude, just do that.
I think it's still recommended to install it through the website, but multiple ways to do it now.
I feel like I feel like it's not. I don't like that a related application is called like Anaconda.
Yeah.
I feel like it's too. I feel like it's too cute, but also stupid. Like it's. I don't know. I'm not a fan.
All right, Troy. Here's the deal. No.
No?
No.
Yours fine. Whew.
There you go. Check it out. Discord. I did the work.
Oh my god. Well, can't let you guys see all my illicit downloads. Just kidding.
This way he might have to type his pseudo password and then we can hack his computer.
You save torrents?
The .torrent.
There's a torrents file.
Not using magnet links like a scrub.
Add Python to path. Click that.
Wait.
It
Python
doesn't
to
matter.
Oh, it's whatever.
It really doesn't matter, actually.
For Windows, like, I don't know.
I use Python from PowerShell.
Well, even if you don't click that, doesn't it install the py? What?
I don't think so.
Do you use .py to launch, or do you try and call the binary directly? Because they have that py launcher now on Windows. That's pretty convenient. And it's
I don't know what this is.
It's in my path. Let me see if. Yeah, Python or Python 3 is not on my path, but py is. So I think that no matter what, it installs the Python launcher into your path.
Oh, cool. Nice.
Coding in Windows feels weird, man.
Yeah, it does.
Closing
Here's an
that.
experiment for our favor, Troy. Can you open up a command prompt, type py?
Use PowerShell.
Either one, whatever.
PY.
No.
No, you get where you have a command prompt, type py.
What?
Yeah.
Just that's it
Yeah.
and enter.
Yeah.
Break his fucking computer before our eyes.
Oh yeah, see there it goes.
System 32.
It works.
Yeah, now you're a new interpreter.
Oh, cool. Okay.
Just close this. Just close this though, and open up the actual one directly where it's a Python 3.7 command line. Yeah, that's there. You go.
But it's so small now.
You
can make it bigger.
Brian.
But the font is so small. How do I make
You
the
can
font
change
bigger?
that. Right click the header and type edit.
Oh, okay.
I actually regularly changed. I actually do this all the time because I use the interpreter a lot just to screw
Properties?
around.
Defaults? Font.
Properties. Yeah. Font. I have like a 14 point, and I changed it to Lucida console because the font that it's built in is like the actual ancient space font.
Let's make the font even bigger.
So I would switch it to like one of their newer monospaced fonts like Consolas or Lucida console or something like that.
So it's a
Oh,
24.
mine defaulted to Lucida console.
Oh, okay. Consolas is fine then, I think.
Bam.
I don't know what PowerShell does by default. But whatever.
I'm gonna use a serif font in my.
A serif font. Dear God.
What the fuck?
It looks so
You monster.
funny. I don't actually, but it looks really funny.
Let me see. Now I want to do this. Wait, I don't even. Does it even have options for that?
The one I'm looking at does.
Oh, I guess Courier New is serifed.
Sun is serif.
Simpson. Oh God. I mean, I guess people used to do that.
Oh man. It looks so.
Is Gothic missing a slash character? Why does it have the yen sign instead of the?
I saw that. I was like, what the hell?
Why are you giving me this option when it's broken? What?
Okay.
Sorry, this is a sidetrack.
Yeah, I got really sidetracked.
It was a good sidetrack, though. Or was it? Here, let me see Consolas. Okay, L and 1 are distinguishable. That's a good test. fonts when L and 1 are the same. Oh no, the worst is capital O and 0 being the same. Who would do such a thing?
Oof, this one is. That's bad.
Yes.
Dude, I would have been so nervous if I was streaming like my first days of coding. Holy shit, I was like a complete moron. I
Same.
didn't understand anything.
I program in Notepad, dude.
Oh, dude, I would totally use Consoleless over Lucida Console. It has better 0 and better L and 1.
I don't know when I like stopped sucking super badly at programming. It like took a while.
Yeah, it's hard to remember sometimes.
I didn't like understand how brackets like were supposed to match up with like the lines that they started from, so they were all just like arbitrarily put in there. My friend was like, what is this shit code? Like,
I accidentally gave Choi 3.7.2. 3.7.3 is the newest.
Rip.
Might be. Now you have a minor bug fix release that you're missing. This is gonna be horrible.
As long as it's not related to
L versus
fonts,
one
I'll
in
be
console
okay.
loss, but everything else is nice.
What were you saying? What'd you say?
One is just a small L in console S though.
Is it?
Yeah, my console.
1 is a small L? No, it's
like
not.
2 pixels shorter.
Why does?
1 has a tilted top.
Okay, I have a question for you guys. Can you see on stream
Mm-hmm.
which one do you think is the 1, and which one do you think is the L?
On the left is the 1. On the right's the L.
Oh damn, you knew. Why does the one on the right look like an L, like more like a
you're
1 to
right,
me?
Edgar. I don't like that.
I don't
Yeah.
like that either.
It shouldn't have a foot. Just have the top on the top.
Anyways,
That's why I said switch to consoleless. The L and the 1 are more distinguishable. And the 0 and the O and the capital O. Those are like some of the first letters I'd look at when choosing a monospaced font for editing in, because I really hate not being able to tell the difference between O and 0.
I think that Courier New suits my aesthetic more.
Okay.
I'm just-
You do
My
you.
fault is Andale Mono.
Andale?
I'm getting sidetracked again.
Is it? There's no accent. Is it? Is it? There's no
I don't know.
accent.
I have no idea. It's funny because in my head I would always.
I don't know. I just assume these are all English words.
It might be. It's just funny to me in my head to like when I see words that are like sound more Spanish to me, but I'm like, and Dale just sounds so gross to me.
I mean, I've never seen this font before, so maybe it's Spanish in origin. I don't know, but it's the font I've been using apparently.
You know, we can find this out
What the?
and take try on greater and greater tangents.
Oh wait. Hello world.
I don't even know what the default is for the terminal in Mac. I haven't
That's what
changed that.
Oh, it's Andale Mono. It just
It
doesn't
is.
show up.
Yeah, there's an accent mark there.
It's Andale Mono. It doesn't show up in the Mac settings, but it's Andale Mono.
Got him.
Oh.
I wasn't just being dumb.
Yeah, it was produced for like made for like an Apple project. This is like the default.
Wait.
Oh, and on your Mac. Yeah, that makes
Yeah.
sense. I was like, I've never seen that font on Windows.
I have never had problems with this font. It is a good font.
Yeah. No, I mean, you know, like, I don't know, it's like memes or like in movies, they even showcase how obsessed like Jobs was about fonts and stuff like that. So like, it kind of makes sense. The Windows is like,
I've never actually watched a single long form media about the guy.
neither have I, but I just know it's like a canonical example of like one of the things he was like kind of like, oh, this is how picky he was. But I think like especially the cmd.exe on Windows is like kind of deprecated at this point, so it defaults to like ancient ass fonts and they don't really bother updating it, I feel like. And the Python interpreter uses basically that terminal. PowerShell I think defaults to different things.
No, I think the Python defaults to PowerShell.
Does it?
Oh wait, maybe it's just Windows 10 fixing shit up.
Because PowerShell, like for me,
It even says in parentheses for technical reasons, and then spells it without the accent.
What's going on in stream over here? He's still doing slicing.
Andale Mono has a sibling called Andale Sans. What?
All right, you could do a sans serif. Is it also monospaced?
Yes. Oh
Maybe,
fuck!
I don't know.
I fucked up.
How dare you? Do you know the one that I really never used is the reversing a string using the step of like using a negative third slice?
I guessed on that.
Oh yeah, I used that in my college. I don't remember why. It honestly just might have been for an exercise and not a real reason.
Yeah, to even do the step, like to use a step at all, like to put
I
2
missed
for
on
every
that.
other letter.
Yeah. I feel like it had to be an exercise or something.
It's like so rare that you actually need to do that.
It's
Alright.
neat that they included it. Like it doesn't harm or hurt.
I mean, as a power of slicing in general, it's nice because, like, maybe like if you're working on a byte, like if it's not a string on string processing, it feels unlikely that you'll need
How
it.
long
But
have I
like,
been
let's say,
streaming for? Almost 2 hours. Wow. Okay, it's bedtime. I've done enough of this.
what was I saying?
Uh,
Oh,
on-
if you're working on bytes, like a byte array, you might have a reason to like do every other byte or some crap.
On next time's episode of Dev, we're gonna do input output
That
and
sounds boring.
IDEs and control flow.
That was interesting.
Control flow, so many exercises.
Yeah, that makes sense.
Good.
Less lectures.
Well, I just mean that like
There should be.
control flow is the part where like
Pretty important.
you don't